Today we will discuss about an entirely new topic called as crystallography. So what is crystallography? Crystallography is a branch of science that deals with the study of geometry, properties, structure. Okay. In fact, this structure will come before property. Okay. Geometry, structure, property, and applications of materials that exist in the form of crystals, that is crystalline substance or materials. This field is known as crystallography. So this definition leads us to another question: what are crystals then? As you already know, crystal is a form of solids. Okay, you might have studied in your previous education that a solid can exist either in the form of crystals or in amorphous form. So before exactly defining what are crystals and what are amorphous substance, let us go back and try to understand the difference between the three basic states of matter, that is solids, liquids and gases. You all agree that okay, when you look around yourself, any material, it can be classified as belonging to either a gas or a liquid or solids. Okay. For example, if you take the water that is present in the bottle in front of your table or in kitchen, okay, it can be classified as a liquid. The atmosphere, okay, the oxygen you are inhaling or the carbon dioxide that you are exhaling, of course we cannot see them through our naked eyes, but we have come to a stage where we can accept that they belong to a state of matter called gases. Okay, on the other hand, you might look around you different substances that can be categorized as solids. For example, the notebook that you are using, the table that you are using for writing, or the chair on which you are presently sitting. There are a lot of materials that we see around us that has different types of uses and applications that come under this category called as solids. Okay, of course this is a very basic classification of matter. There are some materials which cannot be categorized as a solid or a liquid. For example, liquid crystals. Okay, liquid crystals have properties belonging to both solids as well as gases. Okay, so there are some exemptions, but most of the material can be called as either a solid or a gas or as a liquid. In your previous semesters, you have covered topics on gases as well as liquids. In the present semester, we will be focusing on rather one of the important state of matter, that is solids. Why I call it as important is earlier this was the state of matter that was given lesser importance, but in the present technological era, solid state plays a very important role. The electronic devices that you use, the mobiles, the gadgets that you use, okay, the semiconductors, diodes, transistors, okay, the revolution of electronics is because of the different properties of solids and different application of solids. So in the present scenario, it is very important to understand the properties of solids, the structures of different solids, and what are the possible applications. Okay, in our course we will not go into very much detail, but we should at least cover some of the important concepts of solids, especially that of crystalline solids. Okay, that would be very useful for us in the future classes or in the future courses. Okay, so as I already told you, before defining what is a crystalline solid, let us try to understand the differences between solids, liquids and gases. Okay, let me write. So any matter can be classified as belonging to either gas or liquid or solid. The basic question arises: why some exist as gases and why exist as liquids, and why certain substances exist as solids? And there are some examples where a material can exist in different states of matter. You can convert a substance in liquid state into gaseous state, or you can convert a substance from solid to liquid by changing temperature or pressure. So what are the factors that make a substance to exist as a gas, a liquid, or as a solid? Okay, there are two important factors. Okay, there are two factors. Actually, these two factors are opposing factors. Okay, there are two factors that basically decide the state in which the matter exists. What are those two factors? One is the force of attraction between the particles. Particles can be atoms or molecules or ions. Okay, let us discuss about different types of solids later. Okay, depending on the particle that is present in the solid, you can classify solids into different types. Okay, let us simply now call it as particles. So the force of attraction between the particle. The second key factor, which in fact has an opposing influence compared to this factor number one, is the thermal energy or the kinetic energy of the particles. So depending on the magnitude of these two factors, one can imagine the formation of either a solid state or a liquid state or the gaseous state. Okay, let us now officially classify these three states of matter. Difference between gaseous, liquid, and solid state. Gaseous state, liquid state, and solid state. The first difference between these three states of matter can be realized or understood by the way the above two factors play their role. Okay, for that let us try to visualize how the gases behave, how a liquid behave, and how a solid state behave. Okay, so these are very basic things that you have studied from your high school days, so that would be very easy for you to imagine. Okay, can you list some of the important properties of gases, liquids, and solids? Right, gases, we know that they do not have their own shape or they do not have their own volume. Okay, they occupy the entire volume of the container in which they are present, and they acquire the shape of the container. This you know, these are the important observations or properties of gases. On the other hand, what about liquids? Liquids have a fixed volume depending on the temperature, whereas they do not have a fixed shape. For example, if you take 10 ml of water, whether you have taken that 10 ml of water in a beaker or in any burette or in any standard flask, 10 ml will remain 10 ml. Volume will not change. But what happens to the shape of the water? It assumes the shape of the glassware in which you have taken water. So liquids have a definite volume, but they do not have a definite shape. Whereas on the solids, on the other hand, solids, they have definite volume as well as they have definite shape. Okay, so the first difference is gases have no definite shape and volume. Liquids have definite volume but no shape, or no definite shape, whereas solids have definite shape as well as volume. Okay, this is the very basic property of these three states of matter. Now, why do each of the state of matter have such a unique property? Why do gases have no shape or volume? Why liquids have shape, have volume but no shape? Why do solids have definite shape and definite volume? So the answer to this question depends on the two factors which I discussed earlier. One is the kinetic energy of the particles. Second is the force of attraction between the particle. So based on these two factors, we can understand why gases have no definite shape and volume, while liquids have shape, uh, volume but no shape, while solids have definite shape as well as volume. Okay, if you go back to your earlier courses where you discussed gases, okay, you know that the distance between the average distance between gas molecules is very large. Why the distance is very large? Because of a significantly lesser force of attraction between the particles. And what about their kinetic energy? The kinetic energy of gases or their molecules or particles is very large. So as a result of this, gases have no definite shape as well as volume. So how do you categorize gas? In gases, the thermal energy of the particles is much greater than the force of attraction between them. Okay, so as a result, what happens if I have a cylinder in which I have taken a gas? Okay, I have taken a gas, but the molecules have very high kinetic energy that they will move randomly in all possible direction. And since there is no force of attraction between the molecules, okay, we cannot restrict the space in which the molecules occupy. Okay, it is the best example is the atmosphere. Okay, the oxygen, the carbon dioxide that you exhale, okay, that will not remain near you, near your body, uh, forever. Okay, that can easily escape into the atmosphere and it can be found anywhere. Okay, because the force of attraction between each molecules is very less, and because they have very high kinetic energy, they can immediately change their position in the space. So as a result of this, gases do not have a particular shape or volume. Okay, on the other hand, in the case of liquids, okay, the forces of attraction between the particles is slightly, not much greater, but it is slightly greater than the thermal energy or kinetic energy of the molecules or particles. Okay, this is the property of a liquid. What does it mean then? Suppose if in a beaker I have taken certain volume of water, Okay, you can imagine certain water molecules present inside here. Now the force of attraction between two water molecules is slightly greater than their kinetic energy. So you have two forces which are influencing in opposite manner. Okay, kinetic energy of the molecule always tend to increase the volume, whereas force of attraction between the particle always try to decrease the volume. Now in the case of liquids, the force of attraction between the molecule is slightly greater than the kinetic energy. So what happens as a result of this? As a result of this, the molecules are free to move anywhere within the liquid, but it cannot escape from the liquid. I repeat, since the force of attraction is slightly greater than the thermal energy, okay, uh, okay, I will repeat. Since the force of attraction between the molecule is slightly greater than the thermal energy of the molecule, okay, the molecules can move within the liquid state anywhere. It can move anywhere, but it cannot escape from the liquid. It does not have that much kinetic energy to escape from the liquid. Why it cannot escape from the liquid? Because it has slightly lesser kinetic energy compared to greater force of attraction. So the force of attraction between the molecules avoid the molecule from escaping, okay, from the system. Okay, it does not mean that thermal energy is very less. Thermal energy is also significant, but it is less when compared to force of attraction. Okay, thermal energy is less between the molecules when compared in gaseous state. So the molecules can move within the liquid, but it cannot escape from the liquid. But remember student, that is not 100% true. There is a small possibility which we call escaping tendency, that certain liquid molecules may escape from the system. Okay, and that concept you have studied, what is called as vapor pressure. Okay, above any liquid there will be molecules present in the vapor state, and that is a concept that is covered in under vapor pressure or in chemical potential. Okay, that is not a topic that we are going to discuss now. What about solids? Okay, since solids have definite shape and definite volume, you can understand what I'm going to write now. In solids, the force of attraction between the particles is much greater than the kinetic or thermal energy of the particles. Okay, so in solids the particles have very less kinetic energy, so they cannot move from their position. They are almost fixed to a particular point, and because there is a large force of attraction between the particles when compared to the thermal energy, the solids have very rigid shape as well as volume. Okay, so this is the second important difference between the three states of matter. Now the third difference which I am going to tell can be easily understood from the first two difference that we have discussed, that is about the effect of pressure and temperature. So if I exert pressure and temperature, okay, which system can easily be affected by the variation of pressure and temperature? The answer is gas. Okay, it one can expand or compress gas very easily by changing the pressure or temperature when compared to liquid and solid states. Okay, so gases are easily or largely affected by changes of temperature and pressure. If you increase the temperature, it will easily result in expansion of gas. If you decrease the pressure, immediately the gas expands. On the other hand, if you increase the atmosphere, if you increase the external pressure, the gas gets compressed very easily. On the other hand, if you decrease the temperature, okay, the gas can be compressed very easily. Okay, whereas in the case of liquids, okay, the effect of temperature and pressure is in between liquids and solids, in between liquids and solids. Whereas in the case of solids, the effect of temperature and pressure is less compared to solids, sorry, compared to gases and liquids. Okay, pressure has very less effect on the solid state. Okay, sometimes if the pressure is very large, if the applied pressure is very large, the solid may break itself. Okay, other than that, pressure has no such effect on the solid state. Temperature of course can have some effect, but a minor change of temperature, okay, may not affect the state of solid. If the temperature change is very large, it may result in melting of solid or transition of solid from one solid state to another solid state, but that will not happen by a small change in temperature. Okay, so that is the effect of temperature and pressure on three states of matter. The fourth is about the compressibility and density. Okay, since the molecules of gases are widely separated, there is lot of empty space between gas molecules. So gases can be easily compressed by applying pressure, and also they have very low density because very less number of gas molecules occupy a given volume. So gases have large compressibility. You can easily compress gas because there is large number of large empty space between gas molecules. They have large density and low density. Okay, density means the, in simple way, number of particles occupying a given volume, or it is the mass of the particle occupying a unit volume. Since the distance between gas molecules is very large, the number of particles or molecules present in a given volume will be very less. Okay, so they have very less density. On the other hand, solids have low compressibility and high density because the particles in solid states are very tightly packed or closely packed, so there is no distance or space or empty space between the particles. Okay, so it is not possible to squeeze them much closer. So application of pressure has no such effect on the solid state. That is why solids have very low compressibility, and because there are large number of particles in a given volume, they have very high density when compared to gases. What about liquids? Liquids have compressibility and density between gases and liquids, sorry, solids. Their compressibility and density is somewhere between that of a gas and a solid. So these are some of the important differences between the three states of matter. And as I already told you, we here are concentrating only on the one state of matter, that is solids. Okay, how to categorize solids? A solid can exist in a crystalline form as well as amorphous form. Okay, naturally a given compound, if it is a solid, may exist as a crystalline or amorphous solid, but there may be possibility that you can convert a crystalline solid into amorphous or an amorphous solid into crystalline. Okay, there are different ways in which you can convert a crystalline solid into amorphous or amorphous solid into its crystalline form, but remember that is not always possible, but it is possible for some compounds. Okay, now what is the exact definition of a crystal or crystalline substance? and amorphous solids. In your inorganic practicals, when you did salt analysis, okay, analysis of salt, in the preliminary test, okay, you have performed one preliminary test, that is the uh, understanding the nature of the solid that is given to you. Okay, first and foremost, you identified the color of the mixture that was given to you. Based on that, based on the color, you reported what type of ions may be present in the given mixture. After that, you tested the physical nature of the solid, whether the solid is a crystalline or amorphous solid. How did you perform the test? You took a pinch of compound, you hold the compound between your fingers, and you try to uh, uh, press the uh, compound between your fingers. Okay, if it gives a smooth sensation, you uh, decide that it is a amorphous compound. So your inference is that the given mixture is amorphous compound. Okay, if it pinches your finger, okay, if it pricks your finger, it is a clear indication that the given uh, salt is crystalline in nature. So that is one of the important difference between a crystalline solid and amorphous solid. Okay, crystalline solids are very sharp, whereas amorphous solids are very smooth or soft. They have very powder nature. Okay, why crystalline solids are very sharp? That is because one of the very important property that exists within crystals. So now let us define what are crystals or crystalline solids and amorphous solids. Okay, solids based on their physical nature can be crystalline or it can be amorphous. Okay, this is based on physical nature. You can have another type of classification, solids, depending on the nature of particle that is present in the solid. You can have atomic solids, you can have molecular solids, you can have ionic solids, you can have covalent or network based solid materials. Okay, you can have two types of classification. Of course, there may be other types of classification also, but here we will emphasize on these two type of classification. One is based on the physical nature. You can have a crystalline solid or amorphous solid. uh, Based on the nature of the particle that is present within the solid, we have classifications such as atomic solids, molecular solids, ionic solids, covalent or network solids, etc. Okay, first let us emphasize on these this classification. Okay, based on the physical nature, let us define what is crystalline solid. As I already told you, when you press a crystalline material in between your fingers, okay, it gives a itching sensation. Okay, and that is because crystalline solids have, okay, crystalline solids have very flat faces and sharp edges. This is one of the unique property of crystalline solids. Why do they have flat faces and sharp edges? Let us know it later. Well, this is one of the important characteristic physical nature of a crystalline solid, that is they have very flat faces and sharp edges. Okay, where do you have seen crystalline solids? The sugar that you use in the kitchen, okay, or the salt, table salt that you use in the kitchen, all are example for crystalline solids. As you have seen them very closely, okay, they have very flat surfaces and they have very sharp edges. They have a very beautiful regular shape. What is the reason for such a beautiful regular shape? That we will understand later, but that is one of the important characteristic of crystalline solids. And another important characteristic is they have sharp melting point. Okay, they have very sharp melting point. What does that mean? Okay, suppose if you take a compound which exists as a crystal, and if you try to melt the compound by increasing the temperature, the crystalline solid melts sharply at one particular temperature, or maybe in a range of two. Say for example, if the melting point of the compound is 150 degrees Celsius, then that compound melts sharply and completely at 150 degree Celsius. So as you increase the temperature from room temperature, okay, what happens? Until you reach 150, the temperature increases. Once the temperature in the thermometer shows 150, the solid starts melting. At that moment the temperature remains constant, okay, and uh, at that fixed temperature, or the temperature may vary by 1 degree, okay, the entire solid melts. That is what we call sharp melting point. Okay, and another important property of the crystalline solid, which is responsible for the above two properties, is they have very long range order. Okay, what is this? This we have to understand in detail. They have a very long range order. What does it mean? Okay, it means that the constituent particles, what does it mean? The particles which make the solid. Okay, it may be atoms, it may be ions, it may be molecules, okay, whatever. Okay, it is called as constituent particle. The constituent particles are arranged in a very systematic, regular, and very important word, periodic manner. Periodic manner. And this manner of arrangement, order of arrangement, is very long. Okay, I will explain this after I complete the covering the properties of amorphous solids. Okay, another important property of crystalline substances are they are anisotropic. Okay, they may exhibit a unique property called as anisotropic property. What do you mean by anisotropic property? A particular property of the material whose value is different in different directions. Okay, for example, if I have a crystalline solid, if I measure some property of this solid, okay, for example, if I measure the electric field or magnetic field, or if I measure the refractive index, anything, okay, in one particular direction, if I measure some property, it may be optical property in one direction, it has some value. But if I measure the same property in another direction, say for example in this direction, okay, the value of that property will be different in different direction. Okay, and this uh, is called as anisotropic behavior. Okay, and crystalline substances are found to exhibit such type of anisotropic behavior. Now let us list out some of the important properties of amorphous solids. Okay, though amorphous solids have though they have definite shape, hardness, rigidity, okay, like crystalline solids, they have, to some extent, they have definite shape, hardness, rigidity, because they are solids, and solids definitely should have shape, hardness, rigidity. But they that definiteness in shape, hardness or rigidity is somewhat less compared to crystalline solids. Okay, so though they have definite shape, hardness and rigidity, because they are solids, but these definiteness is lesser when compared to crystalline solids. Okay, though they are having all these properties, but the extent to which they exhibit this definite shape, hardness and rigidity is less when compared to crystalline solids. And how we physically distinguish or identify an amorphous solid is they do not have flat surfaces, they do not have sharp edges, they are very soft. The best example is the talcum powder that we use in our daily usage. Okay, that is the best example for amorphous solid. Okay, they have long range melting point. Okay, they do not have sharp melting point, they have a long range melting point. For example, the same compound which melted sharply at 150 degrees Celsius because of its crystalline nature, if I ground it very well and make it amorphous and try to find out its melting point, it will not melt sharply at 150 degrees Celsius. It may start melting at 150 and it may get completely melted at 153 or 154 degrees Celsius. So they will not have very sharp melting point, they will have a range of melting point. Okay, and since they are solids, the particles are arranged in a systematic manner and in a periodic manner, but the order of arrangement is not a long range order, it is a short range order. So that is the important difference between an amorphous solid and a crystalline solids. Okay, so here particles are arranged in a systematic, regular and periodic manner, but the order is very short range. Okay, so though there is some regularity or periodicity in the arrangement of particles within the solid, but it is of a short range order. Okay, let me use a schematic approach to distinguish this short range order and long range order. Okay, before that, let me close this list of properties of amorphous solids. The amorphous solids or amorphous substances are isotropic in nature. What does it mean? If I have a powder sample, okay, if I measure the optical property or electrical property or magnetic property in any direction, okay, in any direction I measure, the value of the property will be same. So the value of a particular property does not depend on direction, it is same in all direction. That is the isotropic nature, and all amorphous substances are isotropic in nature, whereas crystalline substances are anisotropic in nature. Okay, so let me use a schematic approach to tell you what is the meaning of long range order and what is short range order. Okay, suppose if I have certain blocks of solid, okay, kept close to each other, very close to each other, something like this. Okay, you can see that the arrangement of these blocks, solid blocks, is very systematic, very regular and very periodic. What do you mean by periodic? The same thing repeats again and again. Okay, if you look at one point and see how the blocks are arranged at one particular region, that arrangement is same as in another region. Okay, for example, if I concentrate on this particular region, the arrangement in this region looks very same as the arrangement here. Why? Because the same thing is repeating again and again after uh, fixed after certain distance. So that is called as periodic nature. This is the example of long range order. So such type of arrangement exists in crystalline solids. What happens in amorphous solids is there is a orderly arrangement, but the orderly arrangement happens or exists only to some extent. Okay, so if you look at this diagram, this is part of the arrangement in the amorphous solid. Okay, so there is a systematic, regular and periodic arrangement of blocks. But if you look at another region in the same material or in the same sample, the arrangement is systematic, regular, periodic. Okay, but if I look at the overall sample is not orderly arranged. Okay, within this domain there is a systematic periodic arrangement. Similarly, within this domain there is a very systematic periodic arrangement. But if I compare both together, okay, there is some sort of disorderness. Okay, so this is called as short range order. This is orderly arrangement, one type of orderly arrangement. Sorry, this is one type of orderly arrangement. This is also an orderly arrangement. But if I look them together, they are not in the same order. There is slightly disturbance in the two domains. Okay, so this is called as short range order. So in crystalline solid, there is a uniform arrangement of particle throughout the entire sample, whereas in amorphous solids there is a regular arrangement of particle but only within a very small domain. Okay, that is the main difference between crystalline solid and amorphous solid. In our present course we will concentrate mainly on crystalline solids, the structure of some crystalline solids, the geometry, that is the symmetry of certain crystalline solids, and some important applications exhibited by the crystalline solids. Okay, so for that we require some definitions that uh, that has to be understood. Okay, we have to understand some concepts such as lattice points, lattice plane, space lattice. What do you mean by a unit cell? How to uh, what do you mean by unit cell? What are the different types of unit cell? How to calculate the number of particles in a unit cell? What do you mean by a crystal system? What are the different types of crystal system? What the concept of Miller indices, Miller planes. Okay, all those has to be understood. Okay, so this first class we covered a very basic idea about solids, especially crystalline solids. Okay, in the next class we will go into the detail of crystalline solids. But to end this class, okay, let us quickly but very shortly focus on the another type of classification of solids depending on the nature of particle. Okay, now what the solid is made up of, depending on that we can have an elemental solid or an atomic solid, molecular solid, ionic solid, or covalent solids, or also called as network solids. If these solids are made up of elements or atoms, then such solids are called as atomic solids. Okay, generally they are metallic solids. Okay, you can call them as metallic solids. Okay, it may be aluminium or tungsten. Okay, sodium, potassium solids. Okay, they are example for metallic solids because here the constituent particles are atoms. Okay, uh, for that you have to understand the metallic bond. Maybe students from physics background might have studied this metallic bond, or you may be studying the metallic bond in your future classes in final year. Okay, but they are called as metallic solids. What is metallic bond we will not stress here. Okay, such type of solids are called as metallic solids. The second classification is molecular solids. If a solid is made up of molecules, then such type of solids are called as molecular solids. For example, if you have prepared benzoic acid in your laboratory, or if you have prepared aspirin or salicylic acid, okay, some organic compound you have prepared, and you recrystallize them. Once you crystallize or recrystallize those material, you will get crystals of the solids. Okay, so crystals of those compounds. Okay, and those crystals are made up of molecules. Okay, so such type of solids are called as molecular solids. It may be benzoic acid, salicylic acid. Okay, it may be urea. Okay, there are different substances containing molecules. Such type of solids are called as molecular solids because the particles are molecules. Similarly, you can have ionic solids. What do you mean by ionic solids? Right, the particles are ions. Okay, such type of solids are called as ionic solid. The best example you can give is crystals of sodium chloride, potassium chloride. Okay, all these crystals are made up of ions. They contain sodium ion, chloride ion, or potassium ion, chloride ion. And what is the force of attraction between these ions? That is ionic bond. So metallic solids or atomic solids, it is the metallic bond that constitute the solids. In molecular solid, it is weaker forces such as hydrogen bonding or dipole interactions that constitute molecular solids. Ionic solid is because of the ionic bond between the ions. And you have the fourth category called as covalent solids or network solids. The best examples that we can give is diamond, graphite. Okay, they are made up of simple elements, that is carbon, but there is a very large network or arrangement of carbon atoms within the solid. Okay, in diamond you have uh, carbon atoms, sp3 hybridized carbon atoms connected by covalent bonds. Okay, and there is a large network of network or arrangement of atoms. That is why it is called as a network solid. And why it is a covalent solid? Because of the covalent bond between carbon atoms. So depending upon the nature of particles, you can have a classification of solids. Okay, uh, this is about some basic information of solids. Okay, in today's class we discussed about how to differentiate the three states of matter, that is solid, liquid and gases, and how to classify solids depending on the physical nature and depending on the nature of particles. In the next class we will uh, discuss in detail some definitions, okay, related to crystalline solids. Okay, that would be highly uh, technical in nature. We will have some definitions. After defining some entities, we will go into some very important concepts such as Miller indices, Miller planes, symmetries, laws of crystallography, etc. Thank you, students.